If you really think about it, we've been sending all sorts of things into space for a while now to try and figure out what is out there in space itself. We found all sorts of new galaxies, planets of all shapes, sizes, and colors, as well as learned all sorts of space anomalies and how things are made in space. But, as with all things, we are sometimes limited in what we can do based on what we have. That's why NASA was thrilled to finally get their newest space telescope up there into space. Allow us to show you why the James Webb Telescope explores farther into the universe than ever before. The new telescope. The James Webb conception is inspired by the Hubble Space Telescope, the 31-year-old observatory famous for capturing stunning photos of our universe's galaxies. But Webb picks up where its predecessor falls short, says Eric Smith, Webb's program scientist and chief scientist of NASA's Astrophysics division. There's really no telescope like Webb so far, he says. The new observatory, which is slated to launch from northern French Guiana near the equator, is a joint collaboration between the space agencies of the United States, Europe, and Canada. When you see Webb go into space, it's the whole force of human creativity and all kinds of disciplines that push it there. This latest spacebound contraption is unique because of two capabilities. First, it's big, with a 21.3-foot primary mirror that will make Webb the furthest-seeing telescope humankind has ever built. Secondly, Webb views the universe in the infrared, the zone on the electromagnetic spectrum with slightly longer wavelengths than visible light. It will be the only infrared specialized telescope in space that can see long distances. Its closest challenger, Hubble, works primarily in the visible and has a limited infrared viewing range. Anytime astronomers get a new telescope, it's a kid in a candy store kind of thing, says Smith. And they are indeed hoping that they'll find something rather sweet through this telescope. Odds are that they will, because the telescope has a lot of features that will allow it to do more than the Hubble ever could. Looking through space and time. One of the big purposes of telescopes is actually as time machines, because distances look back time, says Daniel Eisenstein, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics. Eisenstein will use Webb's cameras to time travel back to when the earliest galaxies were forming right after the Big Bang. When we look at a distant galaxy light years away, we aren't seeing it in its most recent state. Its distance in light years translates to the number of years it takes for its light to arrive to Earth. For example, the closest galaxy to ours is the Canis Major dwarf galaxy, which is 25,000 light years away. So its light takes 25,000 years to reach Earth. That means when we look at Canis Major dwarf, we're seeing it as it was 25,000 years ago. The further into space scientists can look, the further back in time they can observe a galaxy. Webb, being the farthest-seeing telescope yet, can root out the youngest-looking galaxies humanity can observe. To understand the formation of galaxies, scientists like Eisenstein will look at several galaxies at different life stages and piece together their developmental timeline. Webb's infrared capabilities are also crucial for observing these galaxies. Light from distant galaxies will be stretched out by the expanding universe. By the time the light reaches our telescopes, its original wavelength will have shifted from the visible or ultraviolet to the infrared. Luckily, picking up infrared signals is right up Webb's alley. It's the first time we've had a large, cold telescope in space that can observe these infrared wavelengths, says Eisenstein. The Hubble Space Telescope has managed to capture the shortest wavelength infrared's rays stretched from the bluest of light of faraway galaxies. The retired Spitzer infrared telescope was much smaller than the Webb and couldn't see as far into space. Webb will knock it out of the park in terms of how deep into space and how far back in time it can catch distant galaxies in the act of growing up. Detecting life. If life exists outside of Earth, it will release distinct chemical signatures, such as by breathing carbon dioxide and photosynthesizing out oxygen that can transform a planet. Analyzing the chemicals in a planet's atmosphere will not only allow scientists to look for life, but also enable them to assess a planet's habitability. Webb can detect infrared wavelengths for fingerprinting chemicals such as water and methane present in the atmosphere of exoplanets, which are planets beyond our solar system. Webb contains two instruments that will allow scientists to unravel the wavelengths of infrared signals from solar systems beyond ours, to unweave the colors of the infrared rainbow, so to speak. When an exoplanet photobombs a star that our telescopes are gazing at, the starlight will experience a dip in certain energies corresponding to the chemicals in the exoplanet's atmosphere. If Webb happens to be looking at the right star at the right time, it can chemically analyze the atmosphere of the star's planet by analyzing the blip in the starlight. Exoplanet science as a field is pretty new, says Munaza Alam, an astrophysicist at Harvard-Smithsonian Center for Astrophysics. Since the first exoplanet discovery in 1992, scientists have found thousands of exotic plants teeming in the universe. They're everywhere, he says. That's true, they are everywhere. But just because they're everywhere doesn't mean that they A, have life, or B, are able for us to live on. The Webb telescope will help narrow down the scope, if you will, by showing us what planets are at least possible for either of those two metrics, a thing that would please great many people when it comes to research. Watching stars form. The birthplaces of stars are full of dust. While they make for breathtaking photos, the dust blocks scientists from peering right into the heart of these clouds when they look at them with visible light. Luckily, infrared light from stars can penetrate through the dust to give scientists a whole new take on an old view. Red light can pass through the dust in the Earth's atmosphere better than the shorter wavelengths, the blue lights, says Marcia Reiki, an infrared astronomer at University of Arizona who is the principal investigator of one of Webb's infrared cameras. The same principle explains why infrared light can penetrate even further through dusty galaxies than visible light. If you look at the setting sun, it tends to look much redder than when you look at it in the daytime. It's the same thing. Hubble's limited infrared capabilities have barely scratched the surface for studying stellar formation. Webb's broader infrared range will enable scientists to peer deeper into the dust. Young stars emerge from the dustiest pockets where it's most challenging to see through. Thanks to Webb's high infrared sensitivity and spectacular resolution, scientists might be able to sift through the dust to make out these infant stars with unprecedented detail. And Webb might help scientists figure out how the dust cooks up a star, why stars form in clusters, and how planets form around a star. Black holes. Nothing can escape a black hole, not even light. So, technically, black holes are invisible. Luckily, swirling around black holes is plenty of stuff we can see: stars, dust, and entire galaxies. To study black holes, scientists scrutinize this stellar menagerie, similar to studying a shadow to learn about its shadow-casting object. In the past, scientists have used X-ray telescopes to study specific kinds of physics of black holes. These telescopes look at phenomena that are millions of degrees hot and high enough to produce X-rays, such as the violent shredding of stars wandering too close to a black hole. Webb's infrared instruments will allow scientists to see different goings-on in a black hole's corner, particularly the cooler gases in stars dancing around their invisible neighbor. Where stars congregate is a dusty place. Luckily, Webb's infrared eye will allow scientists to peer past the dusty curtain and see through it all. Webb will provide valuable data to peek into the temperatures, speeds, and chemical compositions of the stellar cloaks of black holes. Scientists can use this data to learn more about the mass and size of the black hole and more about how it snacks on a star. More to be found. As you can see, the James Webb Telescope is one that could very easily help us understand the universe as a whole, or at the very least, understand it better. It may not always be that this telescope finds the greatest of things, but even small discoveries and revelations can help paint a picture of what the universe is, and how it's made, and how things have gone throughout time. That's why NASA and other scientists are eager for pictures to start pouring in from this telescope, because no matter what it finds, it's going to get people talking. So, what do you think? What do you think of this look at the James Webb Telescope and why it has the potential to be something truly special in terms of exploring space? Do you think based on what it should be able to do that it can really show us some new things? What would you like to see from some of the first images this telescope shows off? Let us know in the comments below, and we'll see you next time on the channel.